Today we're going to talk about odd and even functions. A function is even if it is symmetric with respect to the y-axis. One way of telling if a function is symmetric with respect to the y-axis is if the y-axis cuts it right down the middle. So for example, if we look at the parabola in this graph, you'll notice that the y-axis cuts the parabola right down the middle. If I were to bring this line over here, we could kind of see, you can imagine folding the right side of this parabola across with the crease being on that black line, which is the y-axis, and it would totally overlap with the left side. Another way of looking at this, to see if it's symmetric with respect to the y-axis, is pretending that the y-axis is a mirror. If you were to look into the mirror from the right side, you would see the exact duplicate of the right side on the left side, and it would overlap with the left side. So for example, this point here is 1, 1. If we were to look in our mirror, we would see that this corresponding point would lie right on the graph at -1, 1. Notice how that the point on the right side, 1, 1, is 1 unit away from the y-axis and 1 unit up. And on the left side, this corresponding point is also 1 unit away from the y-axis and 1 unit up. And therefore, and that's true for every point on this parabola, and therefore this parabola is symmetric with respect to the y-axis, and it is considered to be an even function because it is symmetric with respect to the y-axis. A function is odd if it is symmetric with respect to the origin. Now, what does that mean? A function is symmetric with respect to the origin if for every point on the graph there is a corresponding point on the graph that has been reflected across both the x and y axes. So for example, let's pick this point on this cubic function right here, which is at 1, 1. And if you were to reflect this point first across the y-axis, you would get it to be over here at -1, 1. And then if we were to once again reflect it, but this time across the x-axis, you would get it to be over here at -1, -1. And notice that after reflecting it the second time, it falls right on the graph. If that is true for every point on the graph, then it's considered to be symmetric with respect to the origin and therefore an odd function. And that is true in this case. If you notice any point on the right side, if we were to reflect it across the y-axis and then the x-axis, it would fall on the graph. Let's look at another example. This is another cubic function. And let's look at 2 more points. Let's look at this point, -1, 1. If we were to reflect this point about the y-axis, it would end up over here at -1, 1. Sorry, at +1, 1. And then if you were to reflect it again across the x-axis, notice it would land right on the graph at 1, -1. And therefore, since after reflecting it across the y-axis and across the x-axis, it lands on the graph, then those 2 points are symmetric with respect to the origin. If that is true with all points on the graph, then we have a graph that is symmetric with respect to the origin. That is true with both of these graphs, and there both of these graphs and the functions are symmetric with respect to the origin, and therefore the functions represented by these graphs are considered to be odd. So once again, a function is odd if for every point on the graph it has a corresponding point that is been reflected across the y-axis and the x-axis and also lands on the graph. Another way of saying that, a function is odd if it is symmetric with respect to the origin. In our last graph example, we're going to give an example of a function that is neither an even function nor an odd function. The one below, this graph below, is neither odd nor even. Let's examine if it's even first. If it is even, it is symmetric about the y-axis. And you can certainly see that if we picked a point, let's say over here, at 1, 0, its corresponding point should be over here at -1, 0, but that point is not on the graph, and therefore that immediately tells you it is not symmetric about the y-axis, and therefore it is not an even function. Now let's examine to see if it's symmetric about the origin. Well, if it's symmetric about the origin, then if we were to take any point on the graph and reflect it across the x-axis and y-axis, it would be also on the graph. And we could pick most points on this graph will not be symmetric about the origin. So for example, if I were to pick this point right here, if this were symmetric about the origin, then if I reflected it across the y-axis, it would end up somewhere around here. And then if I reflect about the x-axis, it would end up somewhere around here. And you can clearly see that's not on the graph. And therefore, as long as at least one point is not symmetric about the origin, then the entire graph is not symmetric about the origin. And this function, represented by this graph, is neither an even function nor an odd function.